Hey, what's up, 8th grade? Catlin here with your help for your cool down on lesson 11. Let's knock this thing out. This is due on Friday. We will continue on with lesson 12 on Friday, but we don't have a quiz tomorrow. So, just a heads up there. We are writing this really small number as a power of 10. And so, to do that, we have to know the place value that it's in, or we have to be able to understand how to count the digits back from the decimal and understand what that is as a power of 10. So if you think about it as the place value of 10, these are tenths, hundreds, thousandths, 10,000ths. This is like 3,400 thousandths. So really, this is the number that we're talking about, 100 thousandths. Okay. Now this is the same as taking the number 34 and multiplying it by 100,000. So you can think about it like that. What we need to do is we need to convert this 1 over 100,000 into an exponent. So 10 to the power of a negative number because it's in the denominator like that. And to find out what that's going to be, you got a couple of different strategies. You can count 1, 2, 3, 4, 5 zeros in that denominator. Or before we even thought about it like this, we could have thought of it as 1, 2, 3, 4, fifth decimal place value, or a place value after the decimal point. So either way that you look at it, it's going to be 34 times 10 to the negative fifth is one way to write it. Also acceptable if you want to write it as a decimal form, you could do 3.4. And since you made it smaller, you need to make this larger times 10 to the negative fourth. All of these are the same thing. This is probably the way that we've talked about it the most. This is where we're going with scientific notation in the future. So either one of those are fine. And then this one right here, we're kind of going the other direction, right? We have 10 to the negative seventh, and we have this decimal point here of 5.64. So if you were thinking about it starting there, and think about how we went from this back to that, well, when it was 34, we moved our decimal point 5 places backwards. And then whenever our decimal was here, we moved it 4 places backwards. So whenever our decimal point is here, we're going to move it 7 places backwards to the left to make this a really small number. So let's say that I moved my decimal point here and I made this smaller. Well, if I make this smaller, this needs to get bigger. So this would be like the same as 0.564 times 10 to the negative 6, right? Which means I need to do 6 more places, which is going to give me 6 more zeros between my decimal point and where this 5 is, right? So this would look like 1, 2, 3, 4, 5, 6, 5, 6, 4, right? And so another way to think about that is the 6, which is where like the tenths place is, because this is kind of the important number here. This is the tenths place. How many of those do we have? Well, we've got 7 of them, right? So 1, 2, 3, 4, 5, 6, 7. You can see that that's in the 7th spot. So that's another way to think about that. We're going to have 6 zeros, or the 7th spot is where that 5 whole number is. The whole number is in the 7th spot back. So 10 to the negative 7th is going to have those 6 zeros there. If I move this 1, 2, 3, 4, 5, 6, 7, I would end up where it says that it is from where I'm at now. Okay, so let me erase that because we don't need that there anymore. Okay, but there's going to be 6 zeros. The 7 is telling you how many times you're moving your decimal back the other way. Okay, you can think about it like that. All right, that's all I got, guys, to help you out with that one. You should be able to go from this to a decimal, and you should be able to take the decimal back to the other form of the exponent by essentially just counting and moving your decimal point the number of times that it tells you. Later.